All right, we are in lesson 3.2, natural selection and evolution. As always, feel free to pause the video and write down your learning goal and then press play whenever you are ready to continue. So let's first start off with a quick vocabulary review of that term, evolution. So evolution and evolved are going to be used interchangeably. It means that things or species change over time. So with this in mind, let's think about what do we think that cause is? Ooh, hint, hint, natural selection. So let's break down the word. And we keep seeing natural and this key word here, select. So let's start off with defining natural selection. And it means that nature selects or chooses who survives and reproduces. This is a very key term or key phrase that we're going to be using over and over again that you should probably just memorize right now because it's 9 times out of 10 the answer to most of your regents and mastery checks. So it may not be about always being big and strong for the best survival strategy. It's about fitness. And fitness means that you are the best at passing on your traits, which are DNA and genes. And these traits that you pass on often help with the survival chances. So traits that improve your survival gives you better chances at reproducing. And that means to have children and babies. So let's take a look at this example in the image. We observe that there is some mice on a dark background, and there's two types of variations. There is a dark mice variation and a light skin mice variation. And over time, we see, oh no, what did the bird do? The bird is eating some of the mice. And over time, we can see that there is less light skin mice and more dark skin mice. So the trait that is best fit in this particular scenario is the mice that are darker in pigment. And that's because it was harder for the birds to see them. Now, traits that are best fit are very different per the environment. So let's take a look at the other example that we have here with the giraffes. Okay, we have the tall giraffe variation and the short giraffe variation. Which variation is better at surviving? In this situation, it's the tall giraffes. That's because they are tall enough to actually reach the trees. And unfortunately, the ones who weren't tall enough, they died. They weren't able to pass on their traits and have future babies who are also short. So those who survive and reproduce are able to give their traits to the next generation. So there are 4 simple rules that explains all life on Earth. One of them is overproduction. So some organisms do really well at producing a lot of offspring like fish. They overproduce many eggs because every fish that hatches doesn't always live to adulthood. So most die when they're born, when they're eaten by prey, or just like the rough conditions of the ocean. And I already told you of this keyword, variation. So in this case, the variation is they're both butterflies, but they have different colors. So by having the different colors, the butterflies have a better chance at surviving if the environment changes. Then we have here selection. So with selection, it could be that in this environment where there is a darker tree branch, that these type of butterflies have a better chance of survival. And then we also have here competition. So when there's limited resources or there's a struggle to survive because they are fighting for resources, then one thing might have a better chance, or one organism has a better chance at survival. Our next guiding question is, how did bacteria outsmart your medicine? And that is through natural selection. So naturally, some bacteria are able to survive because they have traits that makes them more resistant to medicine called antibiotics. Now, these resistant bacteria reproduce over time and they passed on their traits to resistance. And that means that they're not affected by the medication. And this is happening in evolution right now. So because of our abuse um in the medicine world, we're having really strong deadly bacteria that is going out. And again, we have the two types of variations that we can observe in this. We have the normal bacteria and we have the resistant bacteria. And then over time, oh no, we have some die. So the bacteria that were best fit for their environment was the ones that were resistant to the antibiotics. Now, another guiding question that we can ask through the lens of the four guiding principles is, why are New York City rats so big? First, overproduction. Rats produce so much offspring. They have a lot of children all the time. They also have many different variations. So there were some that had genetic differences, such as some are really good at being resistant to poison. Some have the variations of eating anything. And they also have a competition for food. So the strongest rats that are the best at surviving and gathering food tend to created a good survival pressure that allowed that their children to be good at collecting food. And then there are selection. So the rats that were really good at those traits and had traits that fit the New York City environment were able to survive, reproduce, and have more children that were similar to them.